Alright, in this video we talk about instruction formats. So we know that there are a variety of ways in order to encode a instruction. Architecture are differentiated from one another by a number of bits allowed per instruction. For example, 16 or 32 and 64 bits are most common one. Also, we can be differentiated by the number of operand allowed per instruction by the type of instruction and data each can process. Uh, Specifically, the instruction set are differentiated by the following. That's the number of bit per instruction, stack based or register based. Number of explicit operand per instruction, operands location, type of operation, and the type and type operands. So instruction set architecture are measured according to different parameters. The first one, that's the main memory space occupied by a program. This parameter is represented by the amount of space a program requires. The second parameter, that the instruction complexity. Basically that is measured by the amount of decoding necessary to execute an instruction, and also by the complexity of the task performed by the instruction. The third parameter, that's instruction length, basically that's measured in the unit of bits. And the last parameter is the total number of instructions in the instruction set. So in designing an instruction set, several parameters need to be considered. Basically, the first one, that instruction set, instruction length. So whether short, long, or variables. So the short instruction are typically better because they take up less space in memory and can be fetched quickly. However, this limits the number of instructions because there must be enough bits in the instruction to specify number of instructions we need. Um, in addition, the shorter instructions also have higher limits on the size and so the number of operands. On the other hand, the instruction of a fixed line are easier to decode, but it's gonna waste some of the space in the memory. The other parameter also need to be considered in designing an instruction set. That's the number of operands, number of addressable register, and also the memory organization. So whether it's a byte or word addressable. So for example, the memory organization will affect the instruction format, and if a memory has, for example, 16 or 32-bit words. Is not a byte addressable. It's very difficult to accept a single character. For this reason, even the machines just have a 16, 32, or 64-bit words. Are often byte addressable, so that implies that every byte has a unique address, even though the words are longer than 1 byte. The Another parameter need also to be considered in designing an instruction set, the addressing modes. We know that there are many different type of addressing modes. As in chapter 4, we already discussed. Marie used two addressing modes, that the direct and indirect. However, we see in this chapter that a large variety of addressing mode exist as well. So we can discuss more in some other slides. So another concept in instruction format of the endian nest. So basically, the term of endian refer to a computer architecture is by order, or the way the computer store the byte of a multiple byte data element. So virtually all computer architecture today are byte addressable, and metaphors have a standard for storing information requiring more than a single byte. So let's see if we have a 2-byte integer. The integer may be stored so that the least significant byte is followed by the most significant byte, or vice versa. Um, in computer, we have a two type a way to store the information. The first one we call a literal endian machine. So in this way, the least significant byte is followed by the most significant byte. On the other hand, the big endian machine store the most significant byte first. So basically, that's gonna be stored at the lower address. We can see some example later on.